Hiya. Okay, well, welcome back to our series on the head and neck. What we're going to start doing in this video, having in the previous video looked at basic principles of the nervous system overall, what we're going to start doing is thinking about the autonomic nervous system in the head and neck and exactly how it functions. Now this can be quite tricky, okay? It gets quite heavy here, and it's an area which students and doctors and other professionals alike all find very difficult to understand. So we spent a little bit of time trying to work out ways to break it down, but what I would say is that it's probably pretty important that you make sure you're familiar with the rest of the stuff we've covered so far. Okay, so if you haven't been through maybe some of the other videos, or if you're not so familiar with the areas of the skull or the blood supply and nerve supply to the head and neck already, then it would be worthwhile going back and having a look at that before continuing with these two videos here, because otherwise a lot of this might start to be more likely to confuse you rather than actually help you. Okay. What is probably the best way to think about the autonomic nervous system in the head and neck is, rather than thinking, getting all bogged down in the nerves themselves, initially, it's just to think about what the autonomic nervous system needs to do in the head and neck. Now remember what we said in the last video is that the somatic system does basic things like sensation and voluntary motor things, and the autonomic nervous system does the things you don't think about. So in the head and neck, what we're talking about is, for example, controlling the amount of light that's coming into your pupils and getting into your head, into your eye, and the amount of secretions that you're producing, be it through your salivary glands or your nasal secretions. These things you don't think about every day, and these are the things that we need to control. And if we at least have an idea of what we're aiming to do with our autonomic system, then we can then break down how it is that the anatomy is laid out so that we can actually achieve that. So that being the case, what I will tell you is that in these previous video where he was talking about the cranial nerves, or previous videos, the ones that are particularly important here are the 3rd, 5th, 7th and 9th cranial nerves. Okay? These are the ones that are carrying, all of the cranial nerves carry somatic function to some extent, but the ones that carry all of the autonomic neural fibers to the head and neck are the 3rd, 5th, 7th and 9th. We also mentioned the fact that all autonomic nerves have pre- and post-ganglionic neurons in the last video, and I'll quickly recap in a moment where the sympathetic ganglia are. But there's 4 major ganglia in the head and neck near the effector organs, and that you really need to know about, and we'll go through in a lot of detail. And they are the ciliary ganglion, the otic ganglion, the submandibular ganglion, and the pterygopalatine ganglion. So those 4 are going to become very important very soon. Now, if we just quickly recap and we look at this model goes through what I showed in a diagram in the last video, okay? And the bit that I want you to really see here, okay, this is the vertebral column, and we've got here sympathetic chains. Okay, so these yellow bits are the sympathetic chains, and these bulbs are the sympathetic ganglia. Okay, and remember that we said that all of the sympathetic outflow comes from the T1 to L2 vertebral levels. Okay, but that pre- and post-ganglionic neurons can go up and down the track. Okay? And so what you can see is one common thing that the sympathetic system tends to do is it tends to send out branches that hitch lifts with blood vessels. Okay? You can see them wrapping around here, and this is going down towards the pelvis, but the same thing happens up in the head and neck as well. And I'll talk about that more in a second. The other thing to note is that although you can't see it on this model, I will show you in a diagram in a moment, is that the 3 major ganglia that where the pre- and post-ganglionic sympathetic neurons meet for the head and neck are the 3 superior, middle, and inferior cervical ganglia. Okay, and I'll show you a diagram of that in just a moment. There's a lovely little way of thinking about the sympathetic nervous system that Dee actually told me a little while ago, which I quite like, which is that, and it regards the hitching of the rhydon to blood vessels, which is if you think about it in terms of trains, if you wanted to get all the way up to the most northern part of the UK, then the highest major train stop that you could get to, the highest intercity link you could get to, would be in Venous. But if you want to go all the way up to John O'Groats, well, you're going to have to find alternative ways of getting there. You need to hitch lifts all the way up, and so the sympathetic nervous system basically does that. The highest ganglion that you can get to is the superior cervical ganglion, but if you want to actually get sympathetic function all the way up to the top of the body, then you're going to have to hitch a lift, and the things that go everywhere are blood vessels, and so the sympathetic nervous system has a tendency to send out postganglionic neural fibers into plexuses around blood vessels. Okay? So if we have a look at this diagram over here that I've got on the screen, this is another cross-section, and what you can see here, okay, is the superior, middle, and sorry, can you see that? The superior, middle, and inferior cervical ganglia. So this is where the pre- and postganglionic sympathetic neurons of the head and neck are joining, and you can see that the postganglionic ones are starting to hitch around arteries like the internal carotid artery. Okay. And you'll see later that the first branch of the internal carotid artery, the ophthalmic artery, also has branches wrapping around it. Okay? There's also, as it happens, while we're here, it's not a bad time to mention this syndrome, which keeps coming up in medical practice and in medical exams forever, which is Horner's syndrome. Horner's syndrome turns up if, for any reason, the sympathetic flow to the head and neck is blocked, and there's 4 cardinal symptoms which are commonly seen, and they are, if you consider that what the sympathetic system provides your adrenergic response, your adrenaline response to the head and neck. Consider what happens when your adrenaline's pumping. Imagine that a lion's chasing you or something like that. And what you'll find is that you need to open up your pupils as far as possible so you can get as much light in, so you can take in information, so you know what's happening around you. You're going to start sweating, and you're also going to start finding that your blood vessels in this region are constricting, so that they can actually all your blood supply can go to your major organs. Okay? For example, now the reason why I mention those particular things is because if we just come back over here, is that 3 of the cardinal symptoms are, if you have a blocked sympathetic flow, are closure of the pupil, which is meiosis, okay, anhidrosis, which is an inability to sweat, and hyperemia, okay, where the skin becomes flushed. So this is what happens when the sympathetic system is blocked to this region. Okay, the other symptom, which is probably the most obvious one, is a partial ptosis, and this is because the sympathetic nervous system also supplies the smaller of 2 muscles that open up the eyelid, and so it's not able to do it as efficiently. So that's just a clinical little snippet. You can actually see that little muscle that I'm talking about here. This is a cross section of the eye, and that's this thing called the superior tarsal muscle, or Muller's muscle, is the one that I'm talking about. And the bigger eyelid retractor is called levator palpebris superioris, and is supplied by the oculomotor nerve. Anyway, that's just a general that's just a bit of a clinical snippet, seeing as we're talking about the sympathetic nervous system of the head and neck. It seems like a good time to mention that. Now, the other thing that I mentioned, so that was the sympathetic ganglia, okay, heading to the head and neck. But if you look at one of the 4 major ganglia of the head and neck that I mentioned before, the ones that are closer to the effector organs, Dee will talk about that in a little more detail in the next video for how each one of them works. But I thought I'd maybe just show you this diagram to show you how a typical ganglion of the head and neck works. Okay? So what you need to understand, and this is going to be absolutely key to understanding where how everything works in the next video, is this. Okay, is that typical ganglion receives neural fibers based on functional components. Okay, and what it will receive is it'll have traveling through it a somatic neuron, okay, which will be travelling in a cranial nerve. Okay, in this particular example, we've got the fifth cranial nerve just demonstrated here, and it's throwing off a somatic neuron, which is just literally going straight through the ganglion. It's not synapsing or anything like that. It's going straight through. Okay, you'll also have sympathetic fibers, postganglionic sympathetic fibers going straight through. Okay, so they've already synapsed at the one of the cervical ganglia, say the superior cervical ganglion. Their postganglionic fibers have wrapped all around the arteries, and then they will continue straight through the ganglion without synapsing. Okay, and in the meantime, remembering that we are near the effector organs here, the other thing that we'll have is our long preganglionic parasympathetic neurons, which will synapse in the ganglion, and out will come a postganglionic fiber. So usually the preganglionic parasympathetic neurons are travel in either the 3rd, 7th, or the 9th cranial nerve, and the postganglionic parasympathetic fibers tend to, well, always, in fact, travel in the 5th cranial nerve. Okay, so I just want to really point out that diagram to you and get that concept really, really locked down and clear for you, because in the next video that becomes extremely important as a basis for understanding exactly how all the autonomic supply works in the head net. So I hope that helps, and if you come back and see the next video to get a little more detail.